Hi, boys and girls. Welcome back. It's Mrs. Levin from Team Purchase.
Hi, boys and girls. It's Miss Messina from Team Cortland again.
Hi, everybody. It's Mrs. Cabrera from Team Stony Brook.
Hi, boys and girls. It's Mrs. Viola from Team Geneseo.
Hi guys, it's Miss Hidalgo from Team Geneseo.
Hi, it's Missy Schwartz from Team Cortland.
Okay, today what we're going to do is we're going to say, can you use density to identify cubes made of different materials? So this is the kind of lesson that you can't really do at home because you probably don't have cubes of strange materials lying around your house. So we're going to do this more as a demonstration today, although you do have to do the calculations yourself. So have a calculator handy. You're going to need to write some things down, and we are going to measure density. So today I have all these different materials. I have a nice shiny cube. I have a couple of different kinds of wooden cubes. I have, this kind of plasticky thing, and I have this. Now, what materials are these? Can we find out? Yeah, because density is characteristic of a certain material. We're going to be able to take all of these different materials and be able to identify what they are and figure out the mystery of what these cubes are. So today we're not going to have to measure the volume of the cubes. Remember, density is mass divided by volume. We measured the cubes in part 1. All the cubes are the same size, and the volume of each cube is 15.6 cubic centimeters. We're going to measure the mass of each of the cubes, and then you are going to calculate their densities. Can you use your values that you've calculated to identify each cube? So a note that you may want to remember is this, we calculated this was at 15.6 centimeters. It's not exactly 15.6 centimeters because it wasn't exactly 2.5 on each. It was pretty close to 2.5. It was a little tiny bit more than 2.5 on each side, so the volume is going to be a little bit more, but it'll be close enough so that you'll be able to identify it. But don't worry if your numbers aren't exactly the same. So again, our question to investigate today is, can you use density to identify the 8 cubes made of 8 different materials? So I have my set of 8 cubes. You need a calculator, and I have the triple beam balance.
Okay, boys and girls, let's read the procedure together. You can read right along with me. Number 1, the volume of each cube is given in the chart. It is 15.6 centimeter cubed. Number 2, Mrs. Levin will find the mass in grams for each cube using a scale or a triple beam balance. You will need to carefully record your mass in the chart. Then you will use the calculator to calculate the density using the formula that we already told you. The formula for density is density equals mass over volume, or simply D equals M over V. Then you will record it in the chart. Number 4, Table 1 shows a chart that is sectioned off for volume, mass, and density for the unknowns A through H. Let's measure the mass of the sample cube, Miss Levin, and then fill this in.
Okay, so if you look at your chart, you'll see it has sample A, B, C, D, E, and F, and G, and H. So I have the sample. If you can see, I have labeled them. We've already filled in for you that the volume is 15.6 cubic centimeters for each one. You're going to fill in the mass. You're going to calculate the volume. You're going to calculate density by taking the mass and dividing it by the volume with your calculator and rounding it to the nearest tenth. Where it says material on the right column, you're going to look at the chart down below and you're going to see if you can figure out what that material is based on the density you've calculated. We're not going to tell you the answers. You're going to figure it out. Can you do it? Okay, so this first cube, shiny silver cube, what could that be? You put it on the triple beam balance. And can you measure? Now let's find the mass for cube B. This is cube B. It's a black cube. Feels pretty heavy. Let's put this right back to 0. Okay, cube C is shiny and gold. You think this is a lump of gold? Cube C? Cube E? Pretty light. Seems kind of plasticky. Ready for cube F. Cube F is one of the wooden ones. You can see in the answer key, there's pine or poplar, and there's oak. Which one is this? So here we go. Next up, we have another plasticky one. Feels pretty light. This is cube G. And last one is H. It's another wooden one. So that's crazy, isn't it? So some of these blocks were over 100, 140, and some, like this one, 0, 0 point. Then what you're going to do is in the chart right underneath, you will see the chart. It says table 2, approximate densities for various materials. And what you're going to find, see if you, after you've calculated the density, you're going to take a look at the different materials and see if you can identify which one is aluminum, which is brass, which is copper, which is steel, which is PVC, which one's nylon, and which one is oak or pine or poplar. Compare the value you found for the density that you calculated. Density, again, is mass divided by volume. You're allowed to use your calculator and round it off to the nearest tenth. So you're going to compare the value you found for density with the given value in the chart to identify which cube is made out of which material.
So let's explain. Each substance has its own density because of the atoms and molecules it's made up of. The metal, plastic, and wood cubes that we measured each have their own unique density. In general, the density of metal, plastic, and wood can be explained by looking at the size and mass of the atoms and how they are arranged.
For metals, most common metals like aluminum, copper, and iron are more dense than plastic or wood. The atoms that make up metals are generally heavier than the atoms in plastic and wood, and they are packed closer together. The difference in density between different metals is usually based on the size and the mass of the atoms, but the arrangement of the atoms in most metals is mostly the same.
Most plastics are less dense than metal but can have similar density to wood. Plastics are made from individual molecules that are bonded together into long chains called polymers. These polymer chains are arranged and packed together to make the plastic. One common plastic, polyethylene, is made up of many individual molecules called ethylene, which bonded together are to make the long polymer chains. Like most plastics, the polymers in polyethylene are made of carbon and hydrogen atoms. The carbon and hydrogen atoms are very light, which helps give plastics their relatively low density. Plastics can have different densities because different atoms can be attached to the carbon-hydrogen chains. The density of different plastics also depends on the closeness of packing of these polymer chains.
Wood is mostly made from carbon, hydrogen, and oxygen atoms, bonded together into a molecule called glucose. These glucose molecules are bonded together to form long chains called cellulose. Many cellulose molecules stacked together give wood its structure and density. In general, the density of wood and plastic are similar because they are made of similar atoms arranged in long chains. The difference in density is mostly based on the arrangement and packing of the polymer chains. Also, since wood is from a living thing, its density is affected by the structure of plant cells and other substances that make up wood.
How might size, mass, and arrangement of the atoms work together to cause a substance to have a high density? A substance with smaller, more massive atoms that are close together are going to have a higher density because the atoms are packed more atoms in the same amount of space. It's going to give you a higher mass and a higher density.
So let's think about this, boys and girls. How might these factors work together to cause a substance to have a low density? A substance with larger, lighter atoms that are further apart is going to have a lower density.
So we looked at cubes that had the same volume but different masses. Your activity sheet has drawings of 2 blocks, sample A and sample B, made of different substances that both have the same mass but different volumes. Take a look at that example. Please use the formula we learned to answer question 8.
Bye, boys and girls.
Bye.
Girls.
Bye.